Alright. So first of all, what can we do today? Temp memory block. So I realized that we don't actually need these extra curly braces. Like, it still works without them. Let's just enable that. Yeah, well, we need those. We don't need these. Oh. Yeah, so everything else is fine. Let's see here. When main. Actually, what symbols do we have? That's a lot of symbols. Interesting. F9. Run. Yeah, seems to be working. Close that. Alright. But like, what are we actually doing? Oh yeah. We're trying to assign different textures to different rectangles. And this is where we would do that. So let's see, we have a rectangle that's been packed, which has, okay, so we pack it, okay, rect dot, okay, so we have h, okay, xy with height. So this is xy, this xy with height is the position in the atlas. So yeah, let's just store those. And I guess we can store them on float. So like rect to, are we gonna have, well yeah, let's just call it rect2. Not that we're gonna have rect3s, so the rect at less location is rect x, rect y, rect width, rect height. I mean, probably do it this way. Let's go define rect type def struct rect 32, well actually v2 top left, v2 dimensions. So that's what it is. And then just our push. Our push. Well, there's like at this point we know how many textures we have, right? But we are in the middle of temporary memory here, so alright. So to avoid that problem, yeah, alright. So to avoid that problem, let's just put struct arena star permanent and scratch memory initialize it semicolon semicolon, there we go. So if that's the memory. I mean, we are still gonna need this stuff. I don't think we can just put that into a scope, because who knows where that's gonna go. Scratch. Perm. Scratch. There we go. Okay, now I guess I64 size, then void star pointer, size, there we go, size pointer, assert pointer, then per memory permanent, base is pointer, memory permanent, size is size divided by 4 or something. Memory scratch base is pointer plus that, and memory scratch size is size minus that. Okay. Yeah, that works. Okay, now let's go through and see. So temp memory block will start on the scratch, and now we're free to use the permanent storage. So this is memory scratch. This is scratch. I mean, everything that's been allocated right now really is allocated on the scratch. What's this? Oh. This, yeah, okay. I have to modify it a little bit. Okay. I think now it expands to what it's supposed to expand. Yeah, begin on scratch and end temp, yeah. Alright. Ah, so this storage is actually permanent. Yeah, all of this is temporary though. All of this is temporary. Yeah, this R push, we gotta figure that out. Alright, there we go. So memory scratch, memory perm, and I guess assert that scratch used is 0 as well. Alright. Our push. Well, we are trying to retain sort of information about the atlas. So rect struct rect star pointer I64 length atlas locations. It's gonna be something like this. And of course semicolons. Okay, well there's the atlas locations. So that goes in here. Except it's not in our push. We're just gonna set it. Texture index. Well, actually texture index. Yeah, let's just use some kind of index and see what happens with that. Alright, so we're setting it right there. Pointer. Okay, that compiles. Of course, we aren't allocating this. Yeah, okay, so allocation would look like this. Arena, alloc array, memory, permanent. Rect, and how many textures length. Alright, so that. Okay, so let's let that run and see what we get. Okay. Atlas locations. Length 0 actually, hold on. Lang is textures lang. And I guess we can just use that. Alright. Atlas locations, length is 2. And oh my god, alright, hold on, alright. Let's remove that. Can we like go add to watch? Alright. Pointer 2. Well, we can see it here. Alright, 9, 9, 12, 9, 12. Is the other one really 9, 12 also? Well, the whole texture is... Wait. I mean, we're copying through... Well, we aren't really... Yeah, we're only using the rect, right? So, yeah. Now this seems like what it's supposed to be. If we look at the rect here, can we really note? There it is. 912 is the width and the height. And that one is also like that. Interesting. I mean, we can just open up Sprite and verify, I suppose. I mean, we know this is 912. Oh my god. 2013-10, yeah, that sounds right. Is this 2011-12? Ah. Oh, it is. Just drew them exactly like that. Alright, well, fair enough. Alright, well, we're not doing anything with these atlas locations though, so what are we gonna do? Well, we kinda just wanna add them to, like, when we're pushing these rects. Yeah, just add, like, rect instance will presumably have rect instance position dimension. Well, that's for the screen, but there's also the same for the texture. So it's like screen and then text. Like, really, what? That's what that's what it would be. Yeah. Can you do this? Can you do this? Yes. That's good. I mean, this would be screen position and screen dimension. And we also have one of those for the texture, text position. Alright. The format is the same. This would be texture. It's per instance, and there's one instance. Okay, so this seems fine. Alright, HL cell. Of course, we have to describe this here as well. Screen position, screen dimension. Yeah, I guess screen pause, screen dim, like that. And then replace screen with text, and here as well. Yeah, I think that works. Oops. Input pause would be screen pause, and input dim would be screen dim. Okay. And down here, when we're just kind of modifying the position, well, obviously that will be the screen position. Okay, so a bunch of warnings about missing field initializers. I mean, screen. Screen. Okay. So we're not using that information. So the provided input signature expects to read an element with semantic index position. There is no name screen pause, screen dim, text pause, text dim. The provided input signature expects to read an element with semantic index position /0. Does it? Does it though? Does it? Oh. To recompile the shaders. Okay, yeah, that's about right. We shouldn't have any errors. Alright. Now we actually need to use this information that's been passed in. So presumably I would just do wherever I'm pushing rectangles. Here. Presumably I would just do, well, let's add texture information. Text is, and let's say 0, 0. Well, actually, we have both of the things that we need. Right, those are just rects, right? Both of these are just rects. So, rect, there we go. So this would be atlas positions, pointer 0, and the second one is atlas position pointer 1. Text X, yeah. Okay, so now we're passing that in. Presumably. Oh yeah, we don't have pause anymore. It's top left. I mean, it's top left, but we don't actually move those rects around in the manner that would suggest that it's actually the center. But we can address that later. Failed writing, yeah, because something hasn't locked. That's why I need to pack them separately. Alright, well, I need to make sure that we're actually getting that information through. Run the doc, launch, close, mesh. Okay, so 90912 for that one. Instance 1 would be 00912. Yeah, so this seems correct. Yeah. Okay, now it's just the shader stuff. Oh boy. Alright. So UVs, so these are like the reference UVs, that are just in the corners. we need to somehow say that we have a texture position which is in pixels, and well, we also have a texture dimension. With not to, oh my god, not to be confused with this texture dimension. Oh. I mean, this is where it is in the atlas. Maybe I should just rename it to atlas. I mean, okay. I mean, well, I mean, it is under input, so like whatever. Leave it as textdim. Okay. So for any given vertex, that's the reference vertex. We just scale it. I mean, it's the same, right? It's like scale in UV plus pos in UV. Like it's that. Except that we need to work out what these are. Well, position in UV that's pretty simple. That's just text pos, which is in pixels, divided by text dim. So input text pos divided by text dim. So that's the position in UV. Scale in UV. It's just the size divided by that. Is it? I mean, if the dimensions are, if the total size is 100, say width is 100, and the rectangle width within the atlas is 10, then we need to multiply by 0.1. So yes, you just divide them. Text dim divided by text dim is just that. I mean, let's see what that generates, and yeah, I mean, that did generate the correct thing, except that, you know, they don't have a gap, so we see this blending that's happening there on the edge. We can fix that. RenderDoc should still allow us to view the whole texture. Easily enough. Like you just go here, here, oh my god, and there is the whole texture, right? Of course, if the background could be something else, that would be pretty good. Can we make the background something else? Highlight drop? No. I mean, like, yeah. Channels, RGBM, RGBA. No, it's, there it is. Well, I mean, we're picking the color, right? So, oh no, that's not the color that I wanted to pick. Let's just make that black. Wait, that's what it is. Hold on. And then okay, never mind. Like, can it not draw a texture border? Like, really? Like, I mean, it can. Like, it can. I just want this to be a different color, and this checkerboard, I want it to be here. No, either everything's a color or only what I don't want is a color. Anyway, that's the texture. So let's add that 1 pixel gap for one. Finally. Okay, so how would that work? Well, I guess I can commit what I have. Yeah, that's all good. Yeah, that's all good. It's fine. That's fine. Okay. Build, just remove those. Okay. Assign different textures to different rects. Okay. Did I? What's happening here? Why are we like? Why are there so many errors? No, it's all good. Are we good? Yes. Yes. Okay, let's add the stuff we're supposed to add, which is a gap to do. Yeah, there's that thing. So when we are backing into the atlas, we could just say, where is the backing happening actually? Well, backing is happening here. And this is where we're setting the rects to back. Okay. Well, the rects to back just need a 1 pixel buffer. So this is the trimmed texture, this texture. It's a trimmed texture, so there is no dead space around it. We add 1 pixel, except that we need to add 2. Because it's all around, right? So we add 2 pixels to the width and the height, and those are the rects we're going to be packing. Okay. So we have a trimmed, we have a full texture, we have a trimmed texture. Full texture is here, by the way. Trimmed texture is here, this is the rects to pack, this is where the packing happens. Oh my god. Why? What happened there? I said zoom. Alright, so there's the atlas. So we figure out how big the atlas is supposed to be using backtracks. That's fine. This is where we allocate our atlas locations. That's also fine. So we go in, now we have a rect which has that padding. We have a texture which may have dead space. We have a trim texture which has no dead space. Okay, how are we using these things? Well, the rect is the only thing that changed. So destination should be actually +1 because we want to skip that padding, and this should be +1 as well because we want to skip the padding. Let's just wrap it for clarity. It's like, and then we can copy it over. Now atlas location. So the actual texture is at a +1, and its actual dimension is -2. Okay, we failed writing again for some reason. Alright, man, I really need to pack those shaders in a different way. Okay, so we don't have that orange line anymore. Let's see in RenderDoc what was going on. Launch application. Launch. Save. No. I wish it would stop asking me that. Okay, so there's the texture. Okay, well, there is that gap. That, and between them there's a gap. God. What's the button? That button. Yeah, in between them there seems to be a gap, except that it's a 2-pixel gap. I mean, we are kind of wasting, like, we don't really need the 2-pixel gap, like a 1-pixel gap is sufficient. What is the alpha again there? Because each one has its... yeah, you know what, let's not worry about 2 pixels, yeah, let's waste a pixel, whatever, I don't care. I don't care, that's good enough, it's good enough. Yeah, well, I guess that's all it really takes to add that gap. Atlas location is correctly offset. Yeah. Add a 1-pixel gap around. Well, I mean, add a gap around textures in the atlas. Okay, we have to do is... oh, yeah, well, this is probably the next thing, to be honest, because not being able to compile shaders is kind of annoying. Alright. And I reckon the way I'm gonna do that... actually, how am I gonna do that? Like, I do want to call this compiler here as a command, because that way the output will go to the same place where this compiler output is going. So you can, like, catch errors and stuff. Actually, speaking of catching errors, while we're here, yeah, so that error, I mean, it's picked up by the by language support shader tools. So, and a lot of errors are picked up by language support, but not all of them. Yeah, so that's shader tools that's doing that. Ideally, we would just pick them up by the problem matcher. By one of these. I think I already have a problem matcher that works with HLSL in a different project. Oh yeah, well, not anymore. Not anymore. Never mind. Well, we'll just try another one. File location, relative workspace folder, yeah, that's... Is that what it is? No, that's actually absolute. Okay, well... Alright. Regular expression. Well, that's always a lot of fun. I mean, it's Windows only, right? So it's like... We have some kind of letter, which... What's the stand-in for the letter in this JavaScript's regular expression syntax again? I mean, I guess we can just say any character, colon, any character, colon, and then any character any number of times. And then another colon. No, not a colon this time, actually. This would be an open paren, then a digit, then a comma, then a digit, then a close paren, then a colon, then a space, then something like that, yeah, warning or error, then a colon, then a space, and then anything, any number of times, and that's the message. File line, column severity message. Okay, I think that works, maybe. Does it? I mean, they are picking up the same. Are they picking up the same thing, or not? Can I do something here that will... This is not picked up by shared tools. Okay, well, it's picking it up and yeah, okay. I mean, I guess I can disable shader tools. Tools like HLSL tools. Okay, disable. Okay, evidently that's not picking it up. Well, you know what that means. Regex something, I don't know, regex 101. It does not match. I see. Well, presumably because we need to remove these things. So we also need to remove that, and this, and that. It does not match. Try launching the debugger. What's that like? Where is the launch debugger button? Match one failed in 277 steps. Okay, can I press F10? No. Available keyboard shortcuts. Seek one backwards, seek one forward, okay. Okay, so far we are... oh my god. Oh, that's interesting. So it seeks backwards. And it found that, okay. Now it found that, now it found that, now it found that, it's error, yeah. Oh, what just happened there? Oh, there's no colon. I see how it is. So it's warning or error. Yeah, sounds like that. Oh wait, there. So it's warning or error. Then it's some spaces. I guess it's, oh, it's picked up. It's picked up. Oh, okay. Yeah. Alright. Let's enable shader tools. Enable. Okay, it's enabled. Right. Alright, well, that is the problem matcher. That's good to have. Now, of course, I could compile them here, but then into like binaries, right? So instead of outputting header files, just output the binaries, and use those. Let's see actually what that would look like. I just wanna comment that out. Now, okay, so we're gonna have to look at fxc. What is it? Forward slash question mark. Look at the temp help file. And so I've got fh, which is header file, but there's also an option to do. Okay, I think that it's this one, right? Object file. Like, it's not really an object. It's a binary, although it can output a library apparently. Assembly code and hex listing header file. Extract shader PDB and write to given file. Output color and assembly listings, output instruction numbers, output instruction bytes, output hexadecimal literals. I mean, load a binary file rather than compiling. Load a binary file? What does that mean? Why would the shader compiler want to load a binary file? But anyway, FO. So this would be like, you know, build. Oh, build? I mean, it's kind of like an asset, right? The data. And this would be like bin. There's no name for that. So it's like that. And then we would just load that binary instead. So let's see, do we have it? Yeah, we have it right there. Alright. Well, let's see, hold on. Let's comment that out. Turn on compiling the code. Then go into where we're using global, global shaders. There we go. So global shader is only used here in this block. Good. Let's close all that. Well, clearly we just want to load a file, which we kind of already have some code that does that. So let's pull that out. That would be a Windows thing. Bench alignment, yeah. Fatal error, window pro, create dynamic buffer, static. I guess U8 array. Or maybe U8 array. Yeah, that's good enough. Read entire file. I guess this one will just always succeed. Type def struct U8 star pointer I64 lang U8 array. Well, yeah, let's see. Maybe, yeah. Let's try that. And where's this code here? It's just that code. Stir path. I mean, I guess we'll just assume it's not terminated. I mean, we could copy it over to, like, we're gonna have to read into an arena anyway. Right. So we could just say stir path, it's definitely now terminated, is stir format arena %.s lit path. Where are our macros? Are we using these, by the way? The stir macro, like, I don't think it's being used anywhere. Define lit x is x.lang x.putter. I think it's length first. Field precision of type int. Well, like, just you know, just don't worry about it. Of course. I mean, I guess we can just take, like, just tell me what the scratch space is. That's where the path 0 will go. Maybe do it this way. What if it's the same arena though? Oh, that's interesting. I mean, it's probably better to just not do that and instead just do this. Like, we know Windows is just gonna copy that path anyway. So So format it, but then just reset the arena. And yeah, path 0, pointer, generic read, share, open existing, assert, yeah, we'll just assume that we can always do that. Get file size, actually get file size can also fail, right? Return value is non-zero when it succeeds. Assert that it succeeds. Allocate content. Assert that the read succeeded. Actually, does read file return something? Succeeds, it's non-zero. Okay. Bool read file result. Assert. Can never have too many of those. And then, well, close handle h file. That would help. And U8 array, maybe it should just be like U8 array like that, lowercase. Maybe, because really it's like, you know, U8 array result is what? File content and then file size quad part. Return result. Okay, so all of this just goes away then. U8 array file content is read entire file. Path arena scratch. All of this goes away. File content pointer. File content. That's another thing actually. Maybe this needs to be cleaned up a little bit. To do simplify pointer arithmetic. Maybe. Okay, close, and that doesn't need to happen. Okay, so I think this handle also needs to be closed. Close handle that. Yep. Okay, well, is that all that's happening here? Yes. Okay, well, the point of this though was to load the shaders from, you know, binaries. Global shader vs. Okay, well, presumably global shader vs. U8 array shader vs is read entire file string, and it's gonna be data. Oh, let's see. It's gonna be that. Shift. What is it? Shift F10. Yeah. Copy path. Copy relative path. Control K, Control Shift C. Wow, that is a key combination. Yeah, thank you for the backslash. Read it in here. Alright. Define fine. String is str. Let's do that. Str x size of x minus 1. So we'll just do that with literals. Okay, shader vs, and then, well, we'll just, global shader vs is gonna be that pointer, and this is not that, this is lang, like this. Okay, does that work? No, actually. Encoded vertex shader size doesn't match specified size. Well, did it read incorrectly? I mean, that seems... Wait. That's text. Well, did it just not compile the right thing, or what happened there? Like, I thought this was meant to be a binary. Oh, it is. Oh wait, I'm reading in the... What? I thought I copied this. I guess I didn't. Except that we want VS. Does that work? No. Is that one of these? No. Oh, this failed. I'm guessing... Wait, did it fail like here? Is that what happened? Oh, so I don't close it. No, we're using Scratch. Oh wait, hold on. We are. Because this isn't a temp memory block. Temp memory block. Memory Scratch. Now it's a temp memory block. Okay, well that seems to work fine. Let's just make sure we can debug the shader. Mesh viewer, debug vertex. Okay, yeah, we can debug the shader fine. Alright. Okay, well, now let's just do that with shader PS. Shader PS. And all that global shader stuff can go away. Shader vs length. Okay, global. No results. Yeah, that works. Okay, well, let's not be including the shaders then. Include. Yeah, so these shaders need not be included. So let's just remove them. Let's go to build. Let's move these here. Okay, so this is now compiling shaders. Okay, so let's go to git ignore, by the way, and add bin to ignore them. Okay, let's see. Okay, that works. That works. Again, presumably we should not have any writing issues with these binaries. Like, we should be able to just do that. Just do that. Yeah. We can actually compile all three of these things simultaneously, because now they don't, like, we don't need to wait. Because we're not writing header files. So that's kind of done. Like, we're writing that into data, and then it's up to something else to use it. Okay. Yeah, let's leave that there. Okay, well, alright. Toggle focus. There's that. There's this. Close that. Yeah, not including the shaders anymore. Just reading them in. Yeah. Not closing the file because don't need to. Back. I'll compile shaders to binaries as opposed to headers. Okay. I think there's a fairly easy way to get batch to, like, oh, what happened there? Start, I think, if you start and wait, like, is that possible? No. Huh, wait is not recognized. Interesting. So is there a way to start these things in parallel? I don't know. Or is it like, hold on, is it like start B or something? No. Alright. Well, anyway. We've got those two to-dos to do later. Better way, simplify pointers. Yeah. But that's all for today. Thanks everyone.